we will be looking forward. So first I'm going to open the previous code. Okay. For this case. So today, let us start writing some more operations. In the previous session, I have explained about how can we use a flat map operation. How can we use a flat map operation? What is a flat map will do? One-to-many transformations. It will take one input value from the input stream 1, and it will convert that one input value into stream of multiple output values. Similarly, it will take each input value from this stream 1 and will convert it into stream of output values. Finally, it will combine them together, flatten them, all those stream of output values together into one single stream. And for that, we are going to use a method, and that method is called flat map. And we are done with the flat map concept yesterday. And today, 2-3 stream operations I will explain, and I'll conclude the stream because a lot of operations I've explained so far. And further operations you can learn by yourself. Further operations you can learn by yourself. At least some operations I want to explain now today. Okay, let's have a discussion. Let's start with that. Today, we want to discuss about a concept called as grouping by operation. Okay, we want to implement a concept called as grouping by operation. So today we are going to see what is a grouping by. And in order to implement a grouping by, I need employee with a department also, so that it will be easy for me to give some examples. So that's why first I want to create another application. In that application also I have employee, but I am also going to use department field. Employee has a department field also. I'll take only employee number, name, salary, department. These are the 4 fields I want to take for my next example. Let's start creating new example today. I'm not going to modify this example code. I'm just going to start writing the new example code. Okay, let's start. Yeah. Okay, 2-3 operations I will explain, and I'll conclude the stream API. And then I will start and explain completely about and the next feature, completable future. I'll tell you first of all what is future object in the Java concurrency programming. The next we are going to understand about what is future object and what is completable future object. I will explain them. And I'll tell you one use case of how the completable future works. Stream API is the example. Let us consider creating a new Java project. And this Java project I'm creating to perform the stream operations. Let's say stream group API or stream API group. Here, I'm just going to perform 2-3 group operations. Here, I want to create I repeat. I want to create one employee class. I want to create one employee class. But my employee class should contain ID, name, salary, and department. Let's create a new class. Let's create a package, com.example. Class name is employee. And this class should contain attributes. Let us consider, I want to create attributes like, okay, I want to create attributes. I would like to create attributes like int ID. ID, name, and salary, department. Okay, I would like to define a constructor using all the fields. Once the constructor is created with all the fields, next I also want to define two string methods, setter, getters, all those things. Okay, this is my employee class. In employee class, I have a constructor which contains parameters ID, name, salary, and department. These are all the parameters. It is going to accept 4 parameters. Okay, this is a constructor with arguments. Yes. Let us create one service class, and class name is again employee service. Now inside this employee service class, we want to create first one method which can prepare the data. For data preparation, I'm creating a static method, get employees. Public static or private static also correct. Private static. Anyhow, I want to use it within this class only. I do not want to use it in another class at outside. So this method should be accessible within the same class. So for that, I'm just going to make it as a private static method. So private static list of employee, get employees. Okay. Now I just want to create a list. That's it. Nothing is there. I can write directly return statement. Return arrays dot as list of now I can start writing the elements. Each employee, new employee of employee ID 7698, employee name John. Okay, salary $4,000, department sales. And this like this, I want to create multiple employees now. Like this, I want to get multiple employees now. Let us add different numbers and names. 7721, employee name is King. Salary $6,000. Department IT. IT department. This is a research department. $5,000. Name is Blake. And here, employee number 7340, 7349. So next year, 7189, Mary, $6,000, HR department. 7788, his name is Scott, $8,000 sales. Now this employee name is, 7677, Sophia, 4,000, HR department. $7,356, Ellen, 5,000. Okay, let's say department is IT. Like this, you can also add multiple, but as of now, for me, the data is enough. I would like to close it. This is called a data preparation. So this is a method I have created to prepare the data. Now we want to start adding the stream operations here. First, we want to group the employees by department name. Using stream operations, I want to group employees by department. Okay. First of all, if you want to perform any grouping operations, we have to use a class called collectors class. We need a collector object to perform any grouping operations. Okay. Let us start. Let's have a discussion on collectors class. Java.util.collector.collectors. So there is a class available called collectors class in Java 8. Java 8 has provided this. Java.util.stream.collectors. It is a final class. But in this class, you have the methods for group operations. Okay, we have to call a method called grouping by. Grouping by method of collectors class is required here if you want to group. It returns a collector by implementing a group by operation on the input elements. If you want to implement any group by operation on the input elements, you have to call grouping by of collectors class, which returns a collector object. Okay, right. So in stream, we have a method called collect method. So java.util.stream.stream. We should pass this collector object as a parameter to the collect method of stream to convert the result into a collection object, like a list or a set or a map. Okay, to do that conversions, we have to call collect method. Here is a collect method. There is a collect method. This collect method accepts a collector object as parameter. Okay, right? So this method we are going to call collect method by passing the collector object as parameter. Collect method takes a parameter of type collector. And we can create a collector object by using collectors class. In collectors class, I'm going to call this time grouping by, because if you want to perform any group by operation on the input elements, if you want to implement a group by operation on the input elements, I have to use grouping by. So this is what we are going to use. So how do you call this grouping by? It's a static method. It's a static method in the collectors class. It is a static method in the collectors class. So collectors dot grouping by. To the grouping by, I should provide a function as parameter. To the grouping by, okay, grouping by, I should pass a function. Function is a functional interface. And you know, function has a single abstract method. That single abstract method name is apply. It has a parameter of type T, returns result of type R. So now today we are going to call this method grouping by. Okay, it returns a collector implementing a grouping by operation on input elements of type T, grouping elements according to a classification function. It will group the elements of the stream according to the classification function, whatever we are providing the classification function according to that, and returns a result as a map. It returns a result what? Map. What that map contains? Returning the results in a map. Result is going to be in map. So it is going to return me collector of, it's going to return me collector of the input element type T comma, it's going to return me like that. It's for example, I'm grouping by department. Department is a string. So collect, it is going to return me what? It is going to return me a collector object of what I can say. It's going to be a collector object of type employee, and the second type parameter for collector should be map of string comma list of employees. So this particular collectors dot grouping by will apply the grouping operation on the input elements and returns a result into map object. So finally, I'm going to get a map object whenever I call grouping by of the collectors class. It returns a collector object, and that collector object you should provide as an input to the collect method. That collect method returns the result. The collect method returns a result. This collect method returns a result, R for result. R for result. So now we are going to directly write. Okay, we are going to write directly the statement. I will show you how to write the statement now. So directly, it is better to understand directly how to we use grouping by. There is a method available called grouping Look at this case. Let me write the method. First, my requirement is I want to group by department. Employees group by department. I will get what result as a map. That map contains department name as a key, list of employees of the department as a value. Key comma value. Now map stores data in the form of key comma value. So this is the statement. See, get the or group the anything. Group employees by department. I want to group the employees by department. Okay. Look at this. Public. Return type is a map of string comma list of employee. Okay. Let's say, for example, method name is just group employees by department. It's a method which returns me map object, java.util.map object. We are grouping the employees by department. Map stores data in key comma value pair. See, for example, these are the list of employees here. We want to group the employees of this list by department. Sales is one department, IT is one department, research is department, HR is department. For example, sales. This is the map going to be created. The map it's going to create is like this. The map it is going to create is like this. The map is department name as a key. For example, department name sales. Sales department, how many employees are there? 1 and 2. 2 employees are there in sales department. So those 2 employees are added to the list. Here list is a value. This is map. This is a map. This map contains department name is a key. List of employees of the department as value. So it is a map of string comma list of employees. Key type is a string, that's a department name. Value is a list of employees. Sales department, 2 employees are there in this list. Next, IT department, 2 employees are there in this list. IT department has 2 employees are there in the list. It has 2 employees in the list, IT department. Let's say, for example, research department, only 1 employee is there in the list. Only 1 employee is there in the list. This list contains only 1 employee. So department name is key. List of employees belongs to the department as value. Will be stored in a map.
Sir,
This is called grouping the employees by department. Research has only 1 employee. IT has 2 employees. Next, HR has 2 employees. HR has 2 employees. It's a list. This is how it works. This is how it works. Now the department name will be the key. List of employees working in that department belongs to the department as a value. So that's why I'm going to get a map of string comma key type is a string because department name we are grouping by department. We are going to get a map. That map contains key type is a string. Value is a list of employees.
Sir, how it is
That's what we are going to get.
the key, which is the value, like based on what it is deciding the key and the value. That string will be the key, list will be the value.
Come again.
Sir, how it is deciding which will be the key, which will be the value?
You are going to write now. We have not yet written. Just I'm explaining about what the return type. We are going to write grouping by method. We are going to call now. While calling the grouping by, we are going to provide here on what field. Okay, it should apply the grouping by operation. Here I am going to pass department name. Department name is a grouping by field. Based on that, you will decide I should group by department name. Got my point? This function I'm going to call. This method I'm going to call inside the logic. Logic is not yet written. Only just I'm explaining about return type. This is called grouping the employees by department. Now let's see the logic inside. First, I should get all the employees. How can I get all the employees? Call this method, get employees method. Call this method, which returns a list of employee. Which returns a list of employee. Call this method, will get a list of employees. So list of employees is equal to call the method called get employees. Now I got the list of employees now. Now I got the list of employees. Next, after getting the list of employees, we have to start the stream. Stream of employee. Element type is employee. The type parameter is T. The type parameter in generic type is employee. So stream of employee, stream equal to employees dot stream. Next, this stream contains a method called collect method. We are going to call directly collect method on stream. We should call stream dot collect. This collect method takes a parameter called collector. It is overloaded method. One method takes collector, other method takes supplier. But currently I'm going to take collector. I want to call this method called collect with collector. Okay, what should I pass to the collector? Collect method takes a collector object. How can I create a collector object? By using the methods of collectors class. So my operation is what? Group by department. Group the elements in this stream. Apply grouping by operation on the elements of this stream. And that grouping should be performed on department. So collectors is a class. It has a method called grouping by. And we need to specify. There is a function. Function is a function interface. We can pass lambda expression. But to write the lambda expression, I know apply is a method which takes a parameter of type T, returns a result of type R. Result could be any of type T. Here the type parameter is employee. The stream contains a stream of employees. So it has a type parameter. The type parameter is employee type. So E, arrow token. E dot get department. It is taking input as employee, returning output of type string. It's a department name. Get department is a department name. Because it is a function. A function takes a parameter, applies the functionality, given functionality, returns a result. Result type and input type may be same or may not be same because input element parameter is a T type and result is R type. That is all we know because we know about functional interface. That is called function, consumer, supplier, and predicate. So E arrow token E dot get department. E dot get department. E arrow token E dot get department. So now I want to simplify it by using lambda method reference operator. Now I can use method reference operator. What this collect method returns? It returns a map of string comma list of employee. Let's say by department is equal to. My map name is by DEPT is equal to. So this is my lambda expression. This lambda expression I can shortcut with method reference operator. So how can I shortcut it with a method reference operator? I can shortcut it with method reference operator by using class name colon instance method name, because I am calling the instance method on the parameter of the lambda expression only. On the lambda expression argument only, I am calling the instance method. If you are calling the instance method on the same argument only, then we can use class name colon instance method name. That syntax we have to use. So which means the shortcut way of writing this is employee class name colon instance method name is get department. Now I can return this map object by DEPT. Now I will put this in comments. Now we can write in one line shortcut. Return employees dot stream dot collectors dot grouping by department. Employee colon get department. Both are same, but it is a shortcut. So
Sir,
first you create a
grouping
stream
by
object,
static method, no sir?
then you call collect method. Now, first you create a stream. So stream object is created. Once a stream object is created, next step is you call the collect method. This is a collect method. Collectors dot grouping by. This is a method we are calling collectors dot grouping by, and then we have a department. So employee colon department, get department. So this is collectors dot grouping by employee colon get department. This is how we are going to write. This is how we are going to write this operation called group employees by department. This is the classifier. Means based on department, we want to classify, because grouping by accepts a function. Function takes one parameter, returns a result. Parameter is employee, result is a department. So based on department, this grouping by will apply group operation. That group by operation is applied, returns a result as a map. That map contains department name as a key, list of employees of the department after grouping as a value. So the return type must be map of string comma list of employees. Now I want to call this group employees by DEPT method of employee service in main. So I will write one more class here, main class. Let's start creating a new one class we will create. Class name is what? Test. In the test class, first we want to create employee service class object. If you don't want to create object, for example, no need of creating object also, because I don't have an instance variables. So I can directly make this method as a static method. Suppose if I make it as a static method, then static method I can able to call directly with the class name. because this class does not have any instance variables. So there is no need of creating an object for employee service because it does not have any instance variables. Now I can make my method as a static method so that I can directly call the static method with a class name. So class name is employee service. Map of string comma list of employee. Let's say by department equal to employee service dot group employees by DEPT. Since it's a static method, I can directly call the static method with the class name. The class name is employee service. So employee service dot group employees by DEPT. Next, display. To display the elements of a map. To display the elements of a map, we have a for each method directly in map interface also. From Java 8 version, for each method is directly provided in map interface as well. For each method is available for all collections. It's a common method for every collection in Java. For list type of objects, for objects of type set, or if the objects are of another type queue, or even if they are objects of type map, for everyone, for each method is common method. It is available for every collection object in Java from Java 8. So we can able to simply call for each method. So by dept dot for each. Now this for each method accepts consumer, but it is a by consumer. Okay, we know previously consumer, that is a function interface. By consumer also function interface. The problem with the Stream API is it is very big API, lot of interfaces, their methods, and all we need to remember. That's a drawback of Stream API. It has an advantage, at the same time, more drawbacks are also there. Okay, one of the drawback of the Stream API is very large. API is very large and API is a confusing API. That's a problem in the Stream. Okay, until some good practice, one cannot directly work with the streams. That's a problem. There is a by consumer. I'll pass. By consumer. By consumer is another functional interface, like a consumer only, but consumer method name is accept. It takes one parameter of type T, returns no result, return type void. That is consumer. But by consumer takes two input parameters, by two parameters. By consumer takes two parameters as input, returns 0, means void. Let us open by consumer. Without opening that, I cannot explain you. Let us open consumer and by consumer both. This is by consumer. Let us open even consumer as well, so that you can compare consumer and by consumer. This is consumer, we know already. Its abstract method is accept. Accept method takes parameter of type T. Parameter of type T. Returns void. It has a single parameter, takes of type T. Parameter type is T, generic type. And return type is void. That is called consumer. But in by consumer also function interface only. Interface name is by consumer. It's also function interface. It also contains accept method only. It also has accept method. But this accept method has two input parameters, T comma U. T comma U. T for type. T for type. U is another type. T is first input argument. U is second input argument. It takes two input arguments. It has two parameters, return type void. So if I know this, then only I can write lambda expression. Otherwise, I cannot write. I should know before writing the lambda, I must know. What I must know? I should know what is the return type. I should know what are the parameters. How many parameters? Without that, we cannot start writing the lambda expression. So this is the accept method. Now I can start. This for each method of map, the for each method of map object takes by consumer as parameter. By consumer means two parameters I should pass. Two input parameters, t comma u. Okay, two parameters I need to pass for by consumer, not one. Two means in my lambda expression, I should start parenthesis. Because two parameters. If it is single parameter, parenthesis is optional. But for more than one parameter, we must provide parenthesis. We must use parenthesis. So I'm writing for each. I can write two parameters names can be anything. Key comma value. I can write t comma u, otherwise k comma v. K for key, v for value. Map contains key value pairs. First parameter is key, second parameter is value. Now, you want to display the key and you want to display the values. But here value is again a list. So I can write directly SOP statement I can write. I can write SOP statement. SOP. First display the K for key. Plus give some space or arrow, some kind of design. Then display the V. That V is a list of employees. Run this code. Now you got output like this. Sales is the key. Department name is the key. Arrow, our design. It's a list of employee. ID 7698, John, department sales, comma. Again, another employee. It's a list of employees. Scott, department name sales. There are two employees in the list because sales department has two employees. Similarly, you can understand remaining. Research has only one employee. The list contains only single employee. Employee is Blake. Department research. Sales department, two employees. HR department, two employees. Research department, one employee. IT department, two employees. The first operation is grouping by department. This is a group operation. Now, let's group by we will count how many employees are there in every department. Again, grouping by only. But this time, we want to count the number of employees in each department. Grouping by department, we also need to get the count of the employees in the department. Grouping by department only. So same as the previous one. But here the result is, for every department, the map is going to contain department name and a number of employees. The result is going to come like this. The result for the next operation is map is going to contain, map will contain department name and count of employees. For example, department name sales. Count 2. HR. Count 2. Research. Count 1. IT. Count 2. Like this, we are going to get output. Next, our map is going to contain department name as a key, count of employees in the department as value. Nothing but we want to group the employees. We want not group, we want to count the employees in each department. We want to count the employees in each department. We want to count the employees in each department. That's what we want to know. We want to count the employees in each department. Let's see how we can count the employees in each department. Let us see how to count the employees in each department. Okay. How to count the employees in each department. Sure, we will count the employees in each department. We'll see how to count the employees in each department. Again, here also group. If I want to count, first I need to group the employees. All the employees of same department, they are one group. Like that, we need to divide them. First, the total data is divided based on departments. After that, in each section, it will count how many employees are there in this department. So returns the department name as a key, the count of employees as a value. Again, this is also called grouping by functionality. For all grouping by operations, you have to call grouping by method of collectors class. Remember that. Whenever you want to perform any group by operation on the input elements, you have to call grouping by of collectors class. Let's see now how to use that. Count employees by department. Count employees by department. By each department or by department simply. Again, return type is public. See, static. Return type is map of string comma long. Because here we are counting. We want to count how many employees are there. We want to count it. Means I want to get the map which should contain department name as a key, count of employees in that department as a value. I want to get the output like that. Means I want a map to have key as a department name and the value is count of employees. Okay. Method name is, can be any name, count employees by department. So directly I'm writing now because in the previous one. First I should get the list of employees, right? First I should get the list of employees. So after getting the list of employees, next return directly employees dot
Stream.
first stream dot collectors dot grouping by department only.
Yes.
Grouping by employee up to previous code, there is no difference. It is same. Grouping by department. But we have a grouping by with 2 parameters also. Grouping by in collectors class is overloaded method. You have a grouping by is a method which is accepting only one parameter, which is a function. There is a grouping by which takes one parameter is function, first parameter, second parameter, another collector object. So what is the purpose of the second parameter?
Okay.
First parameter is a classifier function mapping input elements to keys. Mapping the input elements to keys. That is called classifier. First parameter is okay. Second parameter, a collector implementing the downstream reduction. The second one is another collector object that will perform the reduction operation. The reduction operation is the reduction operation is we want to count in each department how many employees are there. So in collectors class only, there is a method available called counting, collectors.counting. You can see there is a method called counting, which returns a collector object. Returns a collector accepting elements of the type T that counts the number of input elements. So I can call grouping by with the two parameters. First parameter is function like a previous one, but second parameter is a collector to reduce the operation. It's a reduction operation. So it is going to perform group by operation on the input elements and then performing reduction operation on the values associated with a given key. We also want the same thing. We want reduction operation. Count how many employees are there after grouping. After grouping, what the reduction operation we want? Count the number of employees in each group. So what it will do? It will first implement a group by operation on the input elements and then performs a reduction operation on the values associated with a given key. These two things we should know. So now I can tell you collectors dot, this is a reduction operation, counting. That's it. Now, this is called reduction operation. On each key, each group, it will perform grouping operation on this key department basis. Then this is going to perform count operation on each group. If it is counting on each group, sales is one group, HR is one group, the next key, research is one group, IT is another group. 4 groups. It is going to perform counting on each group. So now we are going to get, it returns a map of key, that is department, it's a string, and the count value, which returns of type long. So map of string comma long. This is called counting the employees by department. So whenever you want to perform any group operation on the stream elements, first you have to call grouping by. Grouping by is of 2 types. First one is only it accepts function as a parameter. Second one, it accepts a function and another reduction operation, a collector object representing the reduction after grouping. 2 parameters we can pass. Now next, let us call this and see the output. So previous output, we want to keep it in comment. This one we want to keep it in comment. We will put this in comment. Then I will go and write map of string comma long. This is count by DEPT equal to employee service dot count employees by department. Then display count by DEPT dot for each K comma V arrow token system dot out dot println of K plus 1 arrow, then plus V. Print the key and print the value. Next, Sales, 2 employees are there. HR, 2 employees are there. Research count is 1. IT count is 2 because 2 employees are there in sales, 2 employees are there in HR, 1 employee is there in research, and 2 employees are there in IT. This is how we have to perform the group operation. Okay, there is same kind of group operation I'll explain with the 2 parameters of group by. This is the last grouping operation I'm telling you now. Okay, this is enough to know. If I explain more also, it is going to be very confusing, difficult. So let us stop grouping by operation and the stream operations by explaining the last example. Last example on streams. Then we'll start with what is completable feature. So last example on stream. Okay, parallel stream also. I'll tell you just what and how the parallel stream works. But first, next we want to group by department only because common we have departments only. Okay, we either group by department or otherwise we can group the employees by their job role, but we never group the employees by ID because ID is a primary key. We cannot group them because every employee has a unique ID. And generally we don't group the employees by name. Mostly we are going to group the employees either by their departments or by their job titles. Okay. But in our employee, we don't have any job title attribute, only department attribute, name, salary, ID, department. Now, let's do the last grouping operation. This time, group by department, we want to get the total salary of the employees. Total salary of the employees by department. So again, grouping by only. Whenever you want to perform a group by operation, only one method, grouping by. But grouping by method has 1 parameter and 2 parameters. It's an overloaded method. So we have to choose whether I should go for 1 parameter or whether I should go for 2 parameters. That we need to choose. Okay, let's start. Just give me a minute. I'll explain. Just give me a minute. Meanwhile, if you want, you can think. You think on this now because see, my next requirement is I'm writing my next requirement. Think on this now. Meanwhile, okay. I need 3-4 minutes time. See, my next requirement is get total salary by department. Means grouping by department. Think on this. Because already 2 grouping by methods I have explained, 2 grouping by operations, the previous one and the current one. The previous one is grouping the employees by only department. This is grouping the employees by department, but counting how many employees are there. This time also same. Up to this, you can copy as it is. No need to think. Up to this comma. Because same operation. But now we need to not count. We need to find the total salary by department, not counting the number of employees. Their salaries you have to sum. So try to search a method in the stream or a method in the collectors class and try to tell me the answer. Okay. Meanwhile, do this. Give me. Okay. After 2-3 minutes, I'll continue.
It's not in that.
Guys. Okay. Now, so we want to get total salary by department, right? So let's see how we can do this. This is a very simple one. We can complete it now. Look at this. Our requirement is we want to complete the stream operation now. So get total salary by department. How I can do that? Get total salary by department. Same as this one only. So public. Okay, public. Return type. Static, of course, I want to static. Right, okay. Static. Return type is map of string comma. But this time it is not counting. We want to get total salary by department, right? Total salary means it's going to be double. Salaries are double type. So map of string comma double. Let's say, for example, the method name is, I want to create a method called total salaries by department. This is a method I want to create. Same code up to this. Same code up to this. But previously, the second parameter, the downstream is reduction operation is previously counting. But this time it is not counting, it is summing. So in collectors class, we have a method, collectors dot. Summing is also there. Collectors dot summing.
Double.
Okay. We have methods called summing int, summing double, summing long. We have to call summing double. Because we want to perform not a counting operation. Reduction is not counting. Not counting on this group by. On this group by, after grouping, then we need to find summing double. Okay, summing double. Summing double is a method which is going to accept a two double function as parameter. It is nothing but okay, summing double. Okay, summing double on what field? It's going to take double function. Means it takes input as a salary, returns. It is two double function, returns as a double. So then it takes employee, that is input. Returns double. It takes function as a parameter. Function takes input, function returns result. Input type is a T, output type is R. R could be anything. So take input as employee, get the salary. Means I can write E arrow token, E dot get salary. But I can, of course, I can also use a shortcut. I can also write shortcut summing double of get salary. E arrow token E dot E is an employee type, no? Oh, it is going to take type T. It's a double function, no? Okay. Summing double. It takes two double function. So let's open the two double function and let's identify what it takes. Two double function. Now this is two double function. It is also one function interface, two double function. Its abstract method name is apply as double. Takes value of type T and returns a value of type double. Method name is apply as double. Returns double by taking a value as type T. Applies this function on the given argument and returns double. Okay. Then first let me close grouping by, then I will close collect, then semicolon. But here I should provide parameter. I'm calling summing double method, which takes two double function. It takes employee salary. Yeah. Employee salary, but I mean, I'm thinking about directly we can write method reference operator employee : get sal. I can write employee : get salary. Because I'm going to call the operation get salary on employee only. Means the lambda expression is E arrow token E dot get salary. So instead of that, I'm writing double colon, but the problem is when I'm writing E arrow token E dot get salary, if I'm writing without using method reference operator, this is what I'm trying to write. E dot get salary. So instead of writing this, now I can shortcut it by using lambda expression. My lambda expression is E arrow token E dot get salary. But what can I do now? I can shortcut it because it is a single statement and it is a method call and it is an instance method, but called on the parameter, lambda parameter. If it is called on the lambda parameter, we can use class name : instance method name. So shortcut is employee : method reference operator get salary. That's it. Now this one we should call from main class. This one we should call from main class. This one we will call from main class. So directly I can call. It is going to be a map of string comma double. Map of string comma double. Sum by department or total by department, anything. Total by DEPT is the name of the map object. Employee service dot total salaries by DEPT. Now total by DEPT dot for each. K comma V, key comma value. Because it's a map stores data in key value pair. Here key is a department name and value is the total salary. Sum of the total salaries of the department. So SOP K, that is the department name. Yes, I'm writing one arrow symbol plus V, sum of the salaries of the department. Let us run this. Department name sales. Sum of the salary is $12,000. HR department sum of salary is $10,000. Research department sum of salary is $5,000. IT department sum of salary is $11,000. Like this. So this is all called grouping operations. It is enough to know up to this. Okay. That is called group operations, grouping by department. Okay. Grouping by department and counting how many employees are there in each group. What is the total salaries of each group? These are all comes under grouping by operations. Oh, correct. These are all called as grouping by operations. This is how you can perform the grouping by operations. Now, yeah, like grouping by, there is another method available called partitioning by. Okay. Partitioning by is also method of collectors class only. Like a collectors dot grouping by, we call collectors dot partitioning by. But what happens based on the given condition? Partitioning by is going to divide into two groups. One stream divided into two groups. That's called partition. I'll give the condition. Condition satisfied elements into one group. Condition false elements into other group. Two groups. One stream is divided into two groups. One group is condition true and other group is condition is false. Example, we have a list of employees now. I'll give one example. Later you explore on this. We have a list of employees now. I want to divide this list of employees into two groups. One group is employees with a salary more than $4,000. Another group is employees having salary less than $4,000. Okay. Are you getting my point? Two groups, same list only, list of employees only, but we want to divide that stream into two groups based on condition. Then we have to use partitioning by method, like group by method. Sorry, like grouping by method. We also have method in collectors class called partitioning by. I'll give an example for that. That's the last. Let's see, one more method I will add to show you how to use partitioning by. But what is partitioning by? It is used to divide the stream elements into two partitions. One partition is condition true elements, other partition is condition false elements. Condition true elements and a condition false elements. If you want to divide them like that, so then we can use partitioning by. And whenever we call partitioning by, it returns a map of first Boolean, because the map contains one partition, Boolean value true, another partition, Boolean value false. The map is going to contain two key value pairs. One key value pair is true comma its value. Second key value pair false comma its value. I'll show you. The last example I'm going to give you on this stream operations using partitioning by. So it is used to divide one stream into two groups. One group is condition true group. Second one is condition false group. Partition is based on given condition. See, I can write something called partition employees based on salary greater than 4,000. I want to give partition now. I want to partition the employees based on salary greater than 4,000. Let's see how we can partition the employees based on salary greater than 4,000. Public static map of Boolean comma list of employees. Because we want to divide the elements of the stream into two partitions. One partition contains list of employees with a salary more than 4,000. Another partition contains list of employees with a salary less than or equal to 4,000. So true group and false group. Condition true group, partition list of employees. Condition false group, partition list of employees. So we are going to get two parameters here. Boolean comma list of employee. So public static map of Boolean comma list of employee. Now we write some method name. Let's say method name is partition by salary. And here I'm writing. First, I need to get the list. Then I want to start the stream. Employees dot stream dot collect collectors dot the method name is partitioning by. It accepts predicate. Predicate means we know condition, right? We know test is a abstract method which accepts a parameter of type T, returns result of Boolean. Return type is Boolean. It accepts a predicate, not a function. Grouping by will accept function as a parameter. Partitioning by will accept a predicate object as a parameter. So predicate is a function interface. We can pass lambda expression. So what is my lambda expression is E arrow token E dot get salary greater than 4,000. This is a given condition. This is the given condition. So it will partition the stream elements into two groups. One is the employees matching with the given condition, true, and other one is matching with false. Means my map is going to contain two key value pairs. One is Boolean true, other one is Boolean false. This is a true list of employees. This is a first partition, and second partition, false list of employees. Let's go to the test. Let's do one thing. Let's call the method map of Boolean comma list of employee. Map can be any name. Let's say, for example, partition map equal to employee service dot partition by salary. Call this displayed partition map dot for each k comma v arrow token first key. So directly we cannot do that. Sorry, it is not like that because we need to get the two groups. Now partition map is containing two groups. I'll tell you. First true group, next false group. I want display separately true group and false group. First group is like this. True group means salary greater than 4,000. So I'll write something like this. SOP better. SOP sal or salary greater than 4,000 partition. First I'm displaying salary greater than 4,000 partition. That is true group. So of course we know map contains a get method. If you want to get an element from map, we have get method. We can get the value of a key by calling get method. One key is true, other key is false. We know that. So directly I'm writing something like this. Partition map. Partition map dot get of true. True is one partition map. One key is true. You know, map contains get method, put method, remove method like this. So get is to get the value of a particular key. If you want to get the value of a specified key, then call the get method. If you want to store the key and value, then put method. If you want to remove a key value pair, then call remove method. Like that, you know, get, put, remove, replace, entry set, key set, like that methods are there in map. Map objects of Java has those methods, right? So get of true. This returns me the value of the key, the associated value, the mapped value of this key. The mapped value of this key true is a list. So list of employees. Okay, we will do one thing. Dot for each directly. For each takes consumer, we know. E arrow token system dot out dot println of E. This is true group. Similarly, false group. False group means system dot out dot println salary less than or equal to 4,000 partition. Same code, but instead of true, I should pass false because the true is one group, false is other group after partition. In place of true, I will write false. And even if you want to shortcut this lambda expression, you can write. We know that how to write. System dot out colon println. By using method reference operator, we can do that. Now we can run and we can see that two groups. So first one is salary greater than 4,000 partition. You can see all these employees are having salary more than 4,000, 6,000, 5,000 up to. Second partition, salary less than or equal to 4,000 partition. There are two employees having equal to 4,000 salary. This is true partition. This is false partition. Like that, if you want to divide, then we have a method called partitioning by. We have two methods. Okay, one is true partition. Second one is false partition. For that, you need to call a method called partitioning by. Okay, you explore on this. Like grouping by, we also have partitioning by. Partitioning by will divide a stream into two groups. One group is condition true group and second group is condition false group. Okay, right. So whatever the examples today we have discussed, this code, this is employee service.java code. Let me do one thing. I will share this with you. And one more thing. Tomorrow also I'll take the session. Tomorrow also I'll take the session Sunday. Okay, at 9 o'clock, the same link, but you join at 9 a.m. Tomorrow morning, you guys need to join at 9 a.m. so that from 9 to approximately I'll take 10:30 or 11. That's it. Tomorrow I will talk about this concurrency API. What is the future object and what is completable future? After completable future, if time permits, I'll just talk about what is the local date, local time classes which are available in Java from Java 8 onwards. To how to work with the new date time classes by using local date class, local time class, local date time class. So these things I will explain if time permits
any
based on that. But first we
prerequisites?
want to discuss about completable future. Tomorrow it is from 9 to around 10:30 or 11. 11 you take from 9 to 11 with the same link. Yeah, somebody is asking me.
Sir, any prerequisite for this future object things like do we need to go through any details?
Multi-threading, just multi-threading.
Okay.
If you know the multi-threading, that's enough. How to create the threads and how to start the threads. That multi-threading base knowledge for completable future.
Okay, sir.
Okay. Yeah. So here I'm writing today. I'll share you this text document name is.
So tomorrow I have one workshop generating AI at 9 a.m.
So, but after that, even for me also not possible. That's why I'm taking at 9. Before 9 not possible. After 11 also I should go. So that's why I'm keeping the session from 9 to 11. Okay. So see, otherwise you can watch this. If in case time is not permitting, you can also go through the recorded session if in case
Okay.
not. Okay. Next one. There is something which is called test. Here I'm giving test code also for you because there is some for each operation available on map. For each method is available for map also. That's why I'm giving the test code as well. The employee class you can create. That is elementary class you can create.
So are you also explaining executor framework?
Completable future means executor only. Okay. Executor framework is a matter of 10 minutes. People are talking about executor framework, executor framework. Nothing is there in executor framework. Only name is having like that. But executor framework completely, if you want to learn, it doesn't take more than 10 minutes. Okay. Right. So anyhow, tomorrow I'll explain about what is executor service, executors, and future object and completable future object. That is what tomorrow's session.
Okay, thanks.
Yeah. Now, everyone download this. It's important. Everyone, I'm sharing the file now.